Good afternoon, bon après-midi à tous. Welcome to this afternoon breakout session about cloud DevOps security, the present and the future. I'm Alain Cormier. I'm the Senior Executive Director at Novipro, and today I will be your host for this breakout session. This afternoon, we'll have Stan Wisseman from Micro Focus, who will be our presenter. Stan Wisseman is the lead for the Security Strategist team for Micro Focus in North America. He has over 30 years of information security experience. Prior to join Micro Focus in 2014, Stan served as the CIO or the CISO for Fannie Mae, with responsibility for information security and business resiliency across the organization. As part of his mandate, he also led the software security consulting practices and helped start the application security program at Fannie Mae. So we're really lucky to have Stan with us this afternoon for this session. If you would ever have any questions, feel free to ask the question in swap card. We'll try to have enough time to answer those questions. About answering those questions, Stan will be also assisted by Allison Hogan that will give us a little bit help in order to respond to your question. So today's session is pretty simple. We will explore the relationship of several major trends in today's IT landscape. The move to cloud to increase flexibility in the infrastructure, the introduction of DevOps to accelerate time to market for custom application, and the ever-increasing need for security in the era of digital transformation. I think the relationship within those three ideas are pretty obvious. When we're trying to embed security into DevOps to get to the DevSecOps or use cloud-based DevOps platforms such as Azure DevOps, there could be some challenges around that. But if your cloud infrastructure is in fact defined as code that comes from the DevOps process, how will that influence your DevSecOps? So today, Stan will entertain us on this topic. I'm sure you will enjoy the session. So without further notice, let's start with Stan. Thank you. Up to you.
Hey, thank you for the introduction. It again is great to be here. My name is Stan Wisseman, and I am a security strategist for Micro Focus's CyberRes, as was mentioned. And today we're here to talk about cloud, DevOps, security, and where is it all going? It's a little bit of a different presentation, but hopefully you'll enjoy it. All right, before diving into this topic though, I'd like to remind folks of our top level messaging. CyberRes is focused on helping organizations achieve desired business outcomes and helping them become more cyber resilient. We have an industry-leading portfolio covering everything from data privacy and protection, identity access management, application security testing, and security operations. Today, we're talking about application security in the context of DevOps and cloud. But if you want to learn more about the broader portfolio of CyberRes, please visit cyberres.com. So, for today's agenda, it's represented by this triangle. We have three major trends of DevOps, security, and cloud. And I'll start by setting the scene by talking about these three things in general. Just a couple of slides for each to trace some of the major trends. But more importantly, we're going to be looking at what happens in the intersections. For example, if we combine DevOps with security, we get DevSecOps. If we combine cloud with DevOps, we start thinking about what it means if you do dev testing in the cloud. And all these things have profound applications to application delivery and application security. So that's what's going to be in the agenda today. Another thing that plays a role throughout the session is this SANS survey. It's a really interesting report that we co-sponsored, and in rethinking the sec in DevSecOps. The traditional way of combining security with DevOps is by adding some checks around security in a DevOps context, and we'll talk about that. But modern trends around cloud make this topic much wider and more interesting. So this survey has a lot of information about that, as well as what data we were able to gather from organizations that are in the midst of dealing with this today. So there are a few nuggets from the report that I'll sprinkle throughout that sort of ground us in reality as to what's really happening out there. But I encourage you to download the report and read it. It's worth it. So let's go to the first section and set the scene. The first one is going to be dealing with the digital transformation, pushing DevOps, security, and cloud, and specifically we're going to be talking about DevOps. There are many ways to look at DevOps, and books have been written about the topic. What you're seeing is a simple model and one way of thinking about how DevOps and the dynamics involved work together. We know there's a huge digital transformation going on, which has been accelerated by the COVID pandemic and is making us more reliant on digital services. The transformation requires an accelerated delivery of applications and new functionality. So that's something that we're achieving through our software development practices. And if you look at how those are evolving, let's go through the history here. And everybody's familiar with the classic waterfall or spiral. And this is inherently a slow process, as we've learned through the years. And many times this big bang approach resulted in big failures. Then Agile became popular, and that fixed some of the issues that was by using a more iterative way of doing development with your business sponsors and developers working together. However, many times it still didn't deliver. And the reason being that developers don't deploy software. It's not their profession or role. You need ops. So when you don't include ops, you're increasing the likelihood of failure if you're really trying to accelerate. And that's why we do DevOps, because, again, the two main characteristics is we get ops into the teams as stakeholders, so we can actually accelerate. And the other thing is the reason why the reason that ops tends to shy away from deploying very often is it's simply risky to deploy that frequently. And so the traditional way of dealing with that is procedures, doing many checks and making it slow and expensive to help ensure that you are not doing something that will add risk to the production environment. And if we want to accelerate, we need to do something else, and we need to reduce that risk of deploying by doing it often and becoming very good at it and automating it as much as possible. So automating is a key hallmark to DevOps. And I think many would agree that this representation, while simple, is a good one. But the question is, where are we now? How are we doing at achieving this objective? So let's look at that, and we can take some lessons learned from the SANS report. It shows that the actual implementation rate is pretty low. We see that the velocity of IT delivery has increased by 14% over the last 5 years. And perhaps you're happy with 14%, but if you look at the acceleration that's needed and the promise of the acceleration with DevOps, that wouldn't be 14%. It'd be much higher. You have stories of organizations deploying into prod multiple times a day, and that is really happening, but it's not the norm. The fact that the survey shows that 14% increase indicates that we still have a long ways to go. Also, automation and automating testing is a key part of DevOps, but it's only happening at half the organizations that were surveyed. And I think that's a pretty low number too. So if you look at what's going wrong and why these numbers are so low, it's an excessive focus on technology, in my opinion. Whereas it really needs to be a cultural and organizational journey. Now, let's move from DevOps over to security as another of those tidal wave movements that we're seeing. So IT security is also heavily impacted by this same digital transformation. There are two vectors that I'm going to describe here. There are others, but here are the two I'm talking about. Accelerated change and bigger reliance on IT. So accelerated change, it causes more inherent risks. And whenever you change something, there's a risk of messing it up from a security perspective. It also means that security staff, the team, has a lot more work to keep up, not only with the velocity, but also with the skills that they need to be able to effectively ensure that security is being part of whatever solution is being rolled out. And whenever new technology is introduced, people need to learn how to secure that technology. I was recently reminded of this by a customer who brought up the fact that Microsoft HoloLens is being used by water treatment plant workers, and how are you going to secure that information that's being shared with them as they're out in the field? Good question. It's not something normally we've thought about, but that's an example of where things are going. And then, the other branch is, bigger IT reliance. Means that more value is at stake. And it also means that it becomes more interesting to be attacked by bad actors. So as the organizations rely more on IT, and that's a bigger target, security is becoming more important. So if you look at this landscape, and I think it's unreasonable to expect traditional IT security departments will be able to deal with this on their own. Given the accelerated requirements to stay up to date and the growing stakes, they can't do it by themselves. So where we are heading is where cybersecurity is everyone's responsibility, and it's integrated into processes rather than being on the side and be considered some separate activity or group, independent of the normal business workflows and processes. The cybersecurity team needs to shift from a governance model to an enabling function. And if you stick with a governance approach, you'll become irrelevant and will just be overruled by the business. They need a different mindset, and they will need to develop a wider skill set. So a lot of interesting things happening in the cybersecurity area. Now, the third major trend is cloud. And if you want to achieve agility and scalability, cloud is an indispensable enabler. The traditional way of dealing with infrastructure isn't going to be fast or agile enough. And that doesn't mean that you have to use public cloud. You could also use private cloud or some kind of hybrid model, which is very popular. But one way or another, you'll need to do something with cloud. Now, a thing to keep in mind when you try and connect cloud with security and DevOps is that you can approach a transformation to cloud in very different ways. One straightforward approach is to lift and shift, where you're essentially taking existing workloads and put them in the cloud as is. And if you're familiar with AWS, for instance, that would mean that you'd choose an EC2 to provide virtual machines, just like you would have VMs or physical machines on-prem. Then you would create a virtual network, and you just transform anything that you need. And then basically you'd be ignoring many of the advanced services that are in AWS and what they have to offer there. Another approach, as you see on the right, is to go much more cloud native. So to develop your applications in such a way that you're aware of and depending on the fact that they are running in the cloud, using those specific technologies and getting the maximum value out of the cloud. And these are very different approaches with different security implications. So when you look at what's happening out there in reality, this is it's very much a hybrid world. Architecturally, you can make a clear distinction between the lift and shift versus the cloud native approaches. But when you look at organizations and what happens, it's almost always mixed. And here's some interesting charts from the SANS report that I want to step through, and it may be a little difficult to read, so let me go through it, and I'll start with the chart on the right. It's the results of a survey on how organizations are deploying applications. And on the left of the chart is on-prem, and then cloud-hosted virtual machines, which equates to a lift and shift approach. And then there are two approaches that are here that would be considered cloud native, and they're using container services or using functions as a service, also called serverless, or in AWS it's called Lambda, or Azure it's called functions, which is the same concept. Now and then on the far right is other. The purple in the chart, the purple bar, represents organizations that are using 100% for one method. So 6% are using fully on-prem, 2% fully using hosted VMs. But across the board, those percentages for the purple, 100%, are really, really low. And even if you add in the orange bar, which is the category of 75% to 99%, it's still low. So the vast majority of organizations are combining methods of deployment. A little bit on-prem, a little lift and shift to the cloud, and a little cloud native and a little other. So a real mix. Now, if you look at the chart on the bottom left, it's a comparison of various cloud providers. It's showing that organizations are using multiple cloud providers at the same time. And again, the number of organizations that choose just one is really, really low, represented again by that purple bar. That may not be a strategic choice. It could be that there wasn't global coordination within the organization, and it happened organically as regions made different choices or different business units made different choices. But however it happened, organizations are spread between cloud providers rather than consuming services from just one. So, having covered these three major topics, let's look at the intersection of these topics, starting with the combination of DevOps and security. Two things come together. We already saw this trend on the bottom of this bottom portion of this chart of how digital transformation requires accelerated delivery that leads to DevOps, that needs a lot of automation. So that's the DevOps side of things. On the security side of things, we know that infrastructure has become more secure, while AppSec, application security, has become less secure. And as a result, applications are an important aspect of the attack surface that's exposed to these bad actors. And application security needs to be addressed. It's no longer an option. Now, if you combine these two things, we know we need to address security, but we also know that any manual method like penetration testing won't fly in the context of DevOps. It's just too slow. So that's why we need to bring security into DevOps to make it scalable, and that's DevSecOps. And as reflected by the notes on the bottom of the slide, is not just about tools, it's also the DevOps culture of going very fast, married to the security culture, which is about managing risks. The other thing is that automation doesn't replace all manual steps. Manual security reviews will still be necessary in some cases, but you need to take that out of the operational process of deploying the software, because then it'll create a bottleneck and that won't be acceptable. So again, let's look and see where we are now by referring to the SANS report. Only 29% of organizations surveyed has automated the majority of their security testing. Fewer than half the organizations have included security tests and reviews as part of coding workflows, a number that I'm really surprised at. So, low numbers, and while everyone is talking about this, you can see that as far as adoption, according to this survey, we still have a long ways to go. Another piece of interesting information I want to highlight from the SANS report is this table. It captures which AppSec practices work. The survey participants were asked about many AppSec application security practices and asked, what's useful and what's very useful, etc. And then rank the practices. And there are obviously too many rows here to discuss them all. So I've extracted the top 3 most useful and the top 3 least useful on the right of the slide. The first 2 of the most useful are not automatable practices. Training is number 1, and manual risk assessments is number 2. And I agree that these are very important, and it goes back to the fact that we can't think of only automation when we consider application security practices. The 2 most effective practices aren't tool-based. The most powerful and effective tool-based thing that you can do is static application security testing, or SAST. And we'll talk more about that in a minute. The top 3 least useful practices were operational runtime shielding, which is trying to protect applications that are inherently insecure by having some additional security layer. So RASP, or Runtime Application Security Protection, falls in that category. CWPP, which is specific to cloud, but essentially the same concept as RASP. And bug bounty programs, where you pay money for researchers to find bugs. Participants said these weren't very effective. And given that SAST, or again, static application security testing, is the most useful way of automating security, and one of the best practices out there, let me highlight now how that works and where that fits in. So if you have a DevOps workflow, code would flow from an IDE to a code repro like Git. It would be picked up by a build server, and if all goes well, it'll get deployed. On that build server, you run all kinds of tests on the code. There could be, initially basic compilation, but you also could do unit testing, functional testing. You could throw in performance testing. But one of the additional tests is security, or SAST. If there are significant findings, you could break the build. So if you have a number of criticals, it breaks policy, you could break the build at that point, or you could, if it's less critical or if it's early in the development process, you can let it continue so that you can track the issue in your issue tracker, and this would also let downstream testing organizations, or QA, for example, have a chance to look at it as well. But that's usually where SAST is fitting into the DevOps workflow. So let's go on to the next intersection. This one is about security and the cloud. So one obvious question you could ask about is whether cloud security is really that special. Because ultimately, cloud service providers provide virtual hardware and need to ensure that what they provision is secure. Of course, you have the responsibility to configure what you get from the CSP, and the approaches of hardening and network least privilege, etc., would be essentially the same as what you'd have to do with an on-prem deployment. If you take this line of thinking, then really nothing special happens. In reality, this is very much depends on how you use the cloud. If you go back to the two methods I talked about before, if you use the lift and shift approach, this way of thinking about what you need to do is more or less correct. But you still have some specific issues that have come up, but in general, that's how you do it. However, if you are using the cloud native approach, again, taking advantage of the capabilities that the cloud provider is having, there are a lot of issues you have to address. And given what we saw in the SANS report, that organizations are using a mix of approaches, there's a lot of new security cloud security ramifications that have to be taken into account. So let's look at a few of those. I recognize that this is a big topic and we can't cover all the different issues that could come up, but we can highlight on a couple. An important one is infrastructure as code. And a useful mental model here is to consider that, we saw what we saw with application development. DevOps enables applications to change fast, that, assurance activities like penetration testings take too long to fit in many times. A similar thing is happening on the infrastructure side, whereas cloud infrastructure deployments, which is almost like a parallel set of activities to the development side of the house, is happening so fast that traditional security reviews are taking too long. And what we are seeing in the cloud world is a trend to automate cloud deployments and configuration. So instead of clicking what you want in a web interface, you'd have that infrastructure as code, and it would automatically be executed. And this area is very much in flux. There are all kinds of different ways you can do it. You can use it declaratively, like the example we see here that is from AWS, or you could leverage an API and use Python code to configure the cloud. There are vendor-specific ways of doing it, like CloudFormation, or tools that try to do things across multiple platforms, like Ansible or Terraform. As to which approach will be dominant, it's really too early to tell. And while this is certainly a trend, it's not adopted by a majority of organizations as of yet. Only a third of organizations are currently using infrastructure as code as the approach for deploying in the cloud. But this is something that is going to be increasing, because, again, if you look at success in the context of DevOps, it really is the automation of the ops side as well. So let's look at some of the implications of this. First of all, from a security point of view, infrastructure as code, or IAC, is actually a good thing. If you have IAC, there's many more ways of controlling it, of checking it, than if configurations are being done manually. But there are also some things to be mindful of. The IAC templates need to be stored securely. It's very important. You don't want to store secrets in repos, which is a huge risk here, because that's a natural place to keep them. Security teams need to get up to speed on this technology and what the teams are doing, and understand what to look for in their reviews. There's also a huge opportunity once infrastructure becomes code. All of a sudden, static application security testing, or SaaS technology, is in a position to be able to identify risks in the infrastructure. And while SaaS, by its very name, is usually about the application side of the equation, it can now deal with infrastructure. And there are a lot of things happening in this space. There's specialized tools like TruffleHog, as well as dedicated tools like Kix and Checkoff, focusing on infrastructure as code. Our own product, Fortify SAST, is very active in adding rules to cover both cases to the product, so we can do these checks as well. So this is something that we're definitely focused on. There are many other aspects of security, and we'll go over a few more here. Containers are often used in combination with cloud and have their own set of risks as well as their own countermeasures, and certainly container security is something that's to be looked at. Microservices are often part of a cloud and DevOps initiative. They carry some risks, but overall, I think microservices are more of an opportunity, especially if you look at how SaaS tools deal with microservices very well. Since scanning a microservice is much faster than scanning a traditional monolith application, you know, that you can get results much quicker. So going to a microservices architecture may actually open up doing true DevSecOps, whereas before that, you may have hit some performance limits as to what you could do with a monolith. And then, cloud comes with many new APIs, which may be out of scope for SaaS. So it's another area to determine whether your SaaS tool does what it needs to do as far as scanning those APIs. So getting into the final leg of the triangle, where cloud and DevOps meet, let's talk about some of the security aspects of that. First of all, if you look at how DevOps is done in the cloud, that's usually not lift and shift. There's a traditional way of doing continuous integration, like using build servers like Jenkins, configure them through a GUI, having big instances that do many builds, usually at night. Now you could lift and shift this approach to the cloud if you really wanted to do that. But that's not the approach that most people are taking nowadays. What's happening instead is that more modern DevOps cloud solutions would be chosen that combine the code repo functionality with the CI functionality, or they're pre-combined, so you don't have to worry about that integration. And importantly, you then configure the continuous integration pipeline as code, so it's not just infrastructure as code, but CI as code. This could run anywhere. You'd see these approaches, a distinction between the central server and the individual runners, as GitLab calls them, or agents, as Azure DevOps calls them. Instead of running on a pre-configured operating system, what would happen is that these builds would run on container images or VMs that start fresh every time. So a very different approach. Now there are many other ways that cloud enables DevOps. In addition to it provides systems like this. As we already discussed, cloud infrastructure is almost inevitable from an agility point of view. If you go for the cloud native architecture, what you're going to see is many services in the cloud that can help you develop more effectively and efficiently. And instead of lifting and shifting a database server to a virtual infrastructure, you could use a database server as a service that's being provided by the provider. This would remove many of the operational concerns and give you much more flexibility. And of course, there are SaaS services that can help you do DevOps that complement what's available from the CSP, from the cloud service provider. And an example of that is our own Fortify on Demand for SaaS and DaaS, which is available through the CSP marketplace. We have very specific things to support Azure DevOps as an example. But there are also some security issues associated with all of this. So let's look at some of the basic, let's look at a basic case, and we'll then look at a couple more complex cases as examples of things you need to consider. If you do DevOps in the cloud, including the CI pipeline, by itself, that's a good thing from a security point of view. You can actually control code very well, control changes to it, can control who can do those changes, so it's all a good thing. There are some risks though, and what we have seen traditionally is access control to code repos or repositories isn't taken very seriously, and that's no longer okay given the type of exploits that we're seeing on code repos. We see that there are many infrastructure risks with infrastructure as code, and we see actual attacks against the development pipeline. The SolarWinds incident that happened earlier this year is a good example of that. Dev environments have got to be secure. Very important thing in general is that the CI pipeline will need secrets to operate because it needs to communicate with other systems, to deploy stuff and access things. These secrets do not belong in the code, and all these systems do provide smarter ways of dealing with those secrets, but you need to ensure that these methods of securing secrets are being used. Again, going back to the security team raising their skill level to know what to look for, or automating that process of looking for embedded secrets. So otherwise, it'll be hard coded, and these tools won't stop you from doing that. Now, one of the more subtle examples, this is what part of a CI/CD integration could look like in GitHub, where you have a workflow. In this case, there's a workflow step called check PR title, and PR stands for pull request. And here it runs a little script. It's actually a bash script where it tries to do regular expression matching and the title with the title, and it obtains the title by expanding a variable that's available from the GitHub complex. This script looks entirely sane. It does what it expects it to do. However, in reality, it's a big security problem because in this title, an attacker could put everything. They could include a double quote and then execute arbitrary commands in that bash script context. They could do bash script injection through a pull request title. And these are the type of attack vectors that nobody was really thinking about a couple of years ago. And that's the kind of thing we have to consider now when we move DevOps to the cloud. That's the intersection of these three. A much more complex case occurred earlier this year with Cove, a code testing coverage tool, where a script was modified by an attacker. They could do so because they obtained credentials from a leaky container image. And using those credentials, they modified a script. And there was a GitHub action that many people were using to use that code coverage tool and it was actually downloading that script and not checking any checksums. So to ensure that there hadn't been any changes. So that script would actually send values of environment variables containing secrets to the attacker, where the attacker could gain access to the victim's system. Again, a pretty complex attack that actually occurred, again, showing that new security issues can occur with a combination of technologies. So, going to some conclusions. We've been looking at major trends and their intersections. We've only scratched the surface. It's a huge topic or set of topics, and I hope you found some interesting nuggets in there. We can't ignore these trends, but at the same time, as the Stan's report shows, we can't assume that they're commonplace yet either. We're moving there. Organizations are making progress there, but not everybody's there yet. We can't think of them in isolation. They are very closely related. And if you combine cloud with DevOps, you've seen there are some subtle security issues that can appear. And there are risks, but more importantly, there's opportunities. Overall, these are positive trends that can help us achieve a more secure state, even though there are problems. And finally, this isn't just a technical problem. The technology to implement securely is readily available. It's more about culture and education, and there are challenges certainly with legacy code that prevents us from getting there as fast as we'd like to. But the core technology is there for us to reap benefits of. I just want to end touching upon our Fortify portfolio. It's a holistic set of capabilities to help deliver application security at scale that ultimately helps enterprises around the world build secure software fast. This stack is built upon a foundation of software security research that rolls up through a wide range of fundamental secure scanning technologies, which underpin modern application security programs. And we also provide application security management capabilities that give you on-prem, SaaS, or hybrid options. We empower Fortify end users with access to our tools through a wide range of interfaces and integrations that can support cloud native as well. So, again, depending on your environment and your progression as you're going down your journey, and you're trying to keep up with the development teams and the ops teams and the transition to workloads into the cloud, we can support those needs with our Fortify portfolio. So with that, I'm going to stop here and see if there are any questions that you may have for me. Thank you very much.
Well, Stan, thank you very much for your presentation. I think it was really helpful for people who were listening on this breakout session. Folks on the session, we're running a little bit out of time for questions. So, Stan, I'll give it to you to give a quick 1-2 minutes to close the session.
All right. Hey, thank you very much. And again, hopefully, folks, you are able to understand some of the dynamics that are going on between these three different tidal waves of cloud, DevOps, and security, and how there are some new issues that arise from the intersection of the three. We are invested in trying to put the SEC in DevOps and support these hybrid environments, and as these things merge together and introduce new vulnerabilities and issues, be there to help secure those as well. Again, come to the booth if you have any questions. We'll be there to answer them. Thank you.
Thank you. Have a great day.
You too.